If you want to try this one on your own, go ahead and pause the video, but I'm going to go through it in 3, 2, 1. So we're told that our shaded area is 119 square inches and the length of EC is 13 inches. We're trying to find the area of the small square EFGD. Let me start by calling this entire length X, and then I'll call the length of my small square Y. Then I can say that the shaded area is the area of the large square minus the area of the small square. Well, the area of the large square is x squared minus the small square is y squared, and the shaded region is 119 square units. Something else I can say about x and y, though, is that they are both legs of a triangle, which is a right triangle because I know that both of my figures are squares. So I could then use Pythagorean theorem to say that a squared plus b squared equals c squared, or x squared plus y squared has to equal my hypotenuse squared, which, if I go back up to my original question, we're told EC is 13. So this hypotenuse length is 13, meaning that x squared plus y squared is 13 squared. I could replace that 13 squared with 169. Now I've got a system of equations that I can go ahead and solve. I'll solve this system using elimination. I can just add. I'll end up with 2x squares. My y eliminates. And on the right, I get 288. I solve, I'll divide by 2. X squared is 144, which means that x is 12. Now we are looking for the area of the small triangle, which has a side length of y. So I do need to find y in order to find the area. So let me go back, plug this back into my Pythagorean theorem, and find my y. So I'll go ahead and replace x and solve. So y, the side length of my small square, is 5. So then the area of my square, EFGD, is going to equal 5 squared, which is 25 square units. And that is all.